Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. My guest is Erika Kohler. She's part of NASA. She deals with planetary studies. We're going to talk about the Venus mission called Da Vinci, and we're going to see what that's about and hear about her work with NASA. So welcome, Erika. Thanks for coming.
Thank you for having me.
Yeah, tell me a bit about your background and how you got to NASA. I would think it's a dream job for people that are interested in space and all this stuff.
Yeah, it's absolutely my dream job. I just, wake up every day. I'm so surprised that I'm here. I have always been interested in the weather, but also planets. And so for me, I kind of built my career to study both of those things. So I'm a planetary scientist. I got my undergraduate degree at the University of Oklahoma, where I majored in meteorology and got to really learn a lot about our own planet's atmosphere. Got to partake in some storm chasing and, do a whole bunch of, fun Earth-based atmospheric activities. And then I moved to graduate school where I got my degree in Space and Planetary Science. And I started learning a lot more about Venus's atmosphere. And, I was able to take a lot of the stuff that I learned from undergrad and what we know about Earth and try to apply it to a completely, brand new world for me where, we see a lot of the same things. For instance, temperature gradients and clouds, but they're actually like completely different to what we experience here. And then now I also do exoplanets. And so I'm just completely changing everything.
Oh, that's cool. For Venus, are there probes that NASA or ESA or whoever has sent that, providing data on the planet and what's going on? Or are they all in orbit only?
All missions that have been sent to Venus in the past 40 years have been orbiters. So before that, though, the USSR and NASA sent a handful of atmospheric probes into the atmosphere. And so we have some data that we use, this in situ data from decades ago, but also, tie that to these orbiting missions that have occurred since then so that we can still, learn a lot about our sister planet. But the Da Vinci is the next mission that's going to be sending an atmospheric probe. And so we're really excited about not only comparing some of our data to the data that was taken over 50 years ago from the time that we actually arrived at Venus, but also to take brand new measurements that were never taken before.
Why atmospheric probes? How come no one wants to do a lander? Or, what are the complications of doing that?
Oh, there are many of us in the community that would love to do some sort of long-lived lander. There are some additional technological issues that come into play there in preparing for it. It's a lot less complicated than a lot of people think, but it's still very complicated to do. And so in some ways, sending an atmospheric probe that is a short term is going to be much more feasible for now. And in the meantime, there are many groups of people that are working towards coming up with new ways to explore the planet, including, long-lived landers, but also long-lived atmospheric things like gliders and blimps type of materials.
Well, I've heard it takes a very long time to get to Venus, even though, the distance between Earth and Venus is much smaller than the amount of time it takes to get there, because you can't go straight. I guess you have to slingshot around and do all kinds of maneuverings to get there. Like, what's that like to get a probe to Venus?
I took an orbital mechanics class in graduate school, and to be honest, I loved the class, but I was also happy that it's not something that I went in to do. But so it does take a couple of months to get to Venus because of what you just mentioned. You kind of have to slingshot around, especially if you're going to be, if you're really interested in setting yourself up to either drop a lander or, drop a probe, or even go into a specific orbit versus conducting a flyby. There's a lot of orbital mechanics that you have to work through, but it's actually fairly quick. It really only takes a couple of months to potentially get into position.
Months still. I mean, that's, if you were able to quote unquote fly straight there, has anyone calculated how long it would take versus how long it takes now?
Oh, I'm sure that calculation is out there, but I don't have it off the top of my head.
No problem. So what do the probes want to measure? You have data you said from 50 years ago. Is it accurate? Is it inaccurate? And what's it missing that you want to get from a new probe?
Oh, yeah. That data is, accurate. There's still a lot of ongoing work that's being conducted, analyzing that data past what was done, at the time. But we're also going to be able to take, 21st century instruments back to the planet. So some of the instruments that Da Vinci is going to bring are actually 5 instruments from within our descent probe. We have 7 instruments in total, but 2 of those will be on our spacecraft, conducting measurements as we fly by the planets. But in terms of our descent sphere instruments, we have 2 mass spectrometers. One is called VMS and the other is VTLS. And they're going to be taking analytical chemistry type sits of the atmosphere as it descends. So they're going to tell us, what the atmosphere is like in terms of chemistry, going to be measuring, some isotopes and noble gases that are going to be able to tell us about the history of the planet, as well as what the current conditions are. And it's going to be able to do that throughout the entire descent. So it's going to tell us about any potential gradients that exist within the atmosphere. Then we
also get a vertical over time look at what the atmosphere is like at different heights.
Yeah, absolutely. And then we have 3 other instruments. We have our Venus Atmospheric Structure Investigation, which is called VOSI, and that's going to be taking all of your, fundamental measurements of the atmosphere as we descend. So things like temperature, pressure, wind speeds. So the stuff that we need to know to put the rest of the measurements in context. Then we have VFOX, which is the Venus Oxygen Fugacity Sensor, and that's going to be taking the partial pressure of oxygen, especially near the surface, and that's going to tell us a lot about the mineralogy and the chemistry of the surface and atmosphere, near environment. And then our final one, which we're really excited about, in addition to the other very exciting instruments, is VINDI, which is our Venus Descent Imager. And it's going to be able to take first time ever spectrographic images of the surface from below the clouds. Now, all of these other types of IR measurements that we have been taken from orbiting spacecraft. And that's what we are able to determine the composition and the topography of the surface from, are those, orbiting imaging, or the orbiting IR measurements. But we'll be able to take those measurements from, again, under the clouds. So, and we're doing this over a tessera region. And so we're going to be able to take these measurements and compare it to the measurements that are being taken from the orbiting spacecraft, and be able to know, excruciatingly fine detail over the tessera, but then extrapolate outwards for the rest of the planet.
Well, so what were the measurements from 50 years ago? Are they trusted? Are they just low resolution? What kind of a picture do they paint now? What are you expecting? Yeah,
well, some of the measurements are, we're also doing, and for example, the measurements that we're taking of the temperature and pressure, we're doing that over a different part of the planet. So we're going to be able to compare it to those past measurements. But yes, we do trust all of that data that was taken before. We just want to compare what we're seeing now to what we're seeing, what we saw then. And then that's also the case for the mass spectrometry measurements. We're taking some of, basically the same type of instrument, but that has been updated. So we're able to get much better precision and much finer details now than we were able to 40 years ago.
Oh, by the way, you mentioned the term fugacity. I haven't heard that from college, so it jumped out at me. I did chemical engineering, bachelor's.
Yeah.
Okay. What is this data going to tell you? Like, what do you imagine that you're going to learn about Venus from the data, and what would be the consequence of it? Like, what's one example, small thing?
Sure. So one thing that we're really interested in is the isotopes. So the reason for this is that by by actually measuring these isotopes, we're going to be able to put Venus in context with the rest of the solar system. So we've been able to take these measurements at a variety of different terrestrial bodies or even small bodies within our own solar system. I'm talking Earth, Mars, even like some asteroids and comets. But we haven't been able to take all of the same isotopic measurements at Venus. And so by one of those, for example, is xenon. We just haven't been able to take that at Venus yet. So by looking at these measurements and how they differ across from each other or how they stay, how they're similar, we're able to make theories and understand better about the formation mechanisms of our entire, our solar system, at least of rocky bodies. So that's one example that we're looking to understand more about.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Okay. Well, when is this mission plan to happen? How soon?
So we are working towards a launch in the 2030, 2031 timeframe, which, feels like a long time, but when there's so much work to be done, the time is just going to fly by.
Okay. So other missions that you're a part of that you think you're going to be really significant in terms of the knowledge they bring back?
Other missions that I'm part of?
Yeah. Other, beyond the Venus mission, are there other ones that you're part of that you think you're going to bring back some really interesting data that we could talk about, where we can go deeper on the Venus ones?
So the only mission that I am a part of is Da Vinci. However, and one thing that I also spend a lot of my time doing is learning about exoplanets. And so some other interesting missions are, of course, JWST. And then as we prepare for the Habitable Worlds Observatory, this is like the perfect crossover for me because Venus, we kind of call it like the exoplanet in our own backyard because historically our observational bias has been to observe these really large, gaseous, hot exoplanets. But with JWST and many of the observational platforms and for the future, we're going to be able to start observing more rocky planets and also like rocky planets that have very appreciable atmospheres. So by studying more about Venus, we're going to be able to extrapolate that information out to all these other exoplanetary systems, looking at these other rocky exoplanets and learning more about them and, why they are the way they are, and also learn a bit more about, possibilities for habitability just by studying, our exoplanet next door.
What planets in our solar system have we never sent probes to? Which ones have we landed on and not landed on?
Ooh, this is a question I'm not so sure I'm able to answer. Because I also may be mixing up where some of these missions are coming from. It's not just NASA.
I know you can't keep track of all missions. I know ESA, the other space agencies.
There's a lot of missions out there, and historically there have been as well. But you know what? I really wish we'd have, personally, I think we should have a ton of missions to every single planetary body. Like the amount of information that we could learn from each planetary body, would be amazing. Just absolutely astounding. We constantly observe Earth. Can you imagine constantly observing all the other planets? We've just learned so much.
Well, it might be a boring job after a while.
I don't think so.
No.
No, we've got Earth scientists that, love their jobs and spend so much time trying to learn, one specific thing and never get bored with it. I don't really see how we'd get bored learning about space too.
No, that's cool. Have you seen, is there a planet that's incredibly difficult to get to, either because of the distance or because of where it's at? Like, is Mercury very difficult to even orbit around or land on? Is it even possible, for instance?
Mercury is difficult to get to because of its proximity to the sun. The gravity well is a bit much to have to overcompensate on. But, there are missions that have gone to observe Mercury. And then, of course, you have the outer planets and also the outer planetary moons. Those can all take a long time to get to, and could take somebody's entire career from planning to finally being able to get the data for some of these, but it's certainly a venture worth taking.
Okay. Well, Meredith, what upcoming missions or submissions that you, are in the hopper that will be maybe, announced soon or that you're working on that you can talk about?
No missions, actually.
Okay. So in addition with the Venus mission, I just wanted to ask a few more questions about it. What is Venus like? Is it incredibly stormy? A probe going down through the atmosphere, will it be eaten up by acid? Are the conditions very harsh? Like, what's it like?
Yeah, absolutely. So Venus itself is a very hot planet. Its surface temperature is about 460 degrees Celsius, which is about believe, if I'm doing the calculation correctly, about 900 degrees Fahrenheit. So the temperature is kind of like being within a wood-fired pizza oven. It's incredibly hot. And then the atmospheric pressure at the surface is about 95 times the Earth's surface pressure. So that's equivalent to diving down about 1,000 meters in the ocean. So it's, incredibly hot. It's incredibly dense and heavy. But it also has these clouds that are composed of, multiple different types of aerosols, but primarily sulfuric acid. So it's acidic. It's just this crazy environment that, I personally would not volunteer to go myself to. It's not exactly the type of place that you'd want to go and spend your vacation at. But these types of weirdness and strange chemistry is kind of what makes it a little bit more special to several of us. There's a possibility that there may be different types of metals on the surface that might have either, come out as a result of weathering of the surface that we don't really experience here, but also there's a hypothesis that some of these materials may have been actually condensed out of the atmosphere. So in that case, you're talking about potentially metal clouds and metal snow that's landing on these high elevated regions. And so the chemistry of Venus is absolutely fantastic. I think it's a lot of fun. It, has created more questions than there are answers. And even when we send Da Vinci, one of the things I think we're most excited about is not just answering some of the questions that we already have, but learning what sort of questions we're going to have as a result of the new data.
Yeah, that's really interesting. Are there particular elements or compounds that you think would be very, very unusual in Venus's atmosphere? Water or, again, how metals behave, et cetera. Is there a payload that, the probes are going to take so it could be exposed to the, the chemistry in the air and maybe on the ground?
Yeah. So there are, we've got certain things that we are looking for. I mentioned earlier about the noble gases and specific types of isotopes, one of which is the D to H ratio, which is basically how much heavy water is in the atmosphere, because by measuring what that ratio is, it tells us about whether or not Venus could have been more Earth-like in its past. And so by Earth-like, what I'm meaning is, whether or not it might have had oceans on its surface. So definitely more of temperate environment, more of what we experience now. And then at some point in its past, it started getting warmer and warmer and warmer, and that has made all of those potential oceans evaporate and had left it with this, hot, barren, surface environment that it has now. But on the other hand, it may have always been the type of environment that we see now. It may have always been really hot with this really high pressure from an atmosphere that's composed of 96% carbon dioxide. It may never had water on its surface, but we don't know the answer to that. And so with Da Vinci, by being able to take these D2H measurements, as well as some other measurements that we'll be able to take, that's one of the questions that we're going to be able to answer, or at least that we hope to answer.
Yeah. Because of Venus's atmosphere, what does asteroid bombardment look like as compared to Earth? What would happen or what appears to have happened if asteroids enter Venus's atmosphere? Do they get chewed up faster? What happens?
Yeah. So Because of the atmosphere at Venus, some of the types of asteroid impacts or meteor impacts that Venus receives, there would actually be, because of Venus's very thick and, heavy and dense atmosphere that is so different from Earth, we actually wouldn't see evidence of many asteroids and meteors hitting its surface because the impacting body would actually just get kind of broken up more in the Venus atmosphere, as opposed to if that same sized body hit Earth. Because, we get hit every day with small amounts of rocks essentially thrown at us by space, but the majority of those, get burnt up in the atmosphere. The same thing happens at Venus, but larger bodies would actually get broken up in the atmosphere. One interesting thing...
Why is that, by the way?
Oh, just because of the nature of the atmosphere, just being so thick and heavy, the rocks just burn up more in there.
Okay, I understand. Go ahead. You were saying one interesting thing as well.
And then also they'll float down slower, I guess. So it's got to be a pretty appreciable sized rock to be able to actually reach the surface of Venus.
Yeah, I guess with the atmospheric drag, they would maybe heat up just like they would on Earth, but it's already so hot. So I wonder if it would get up to, well over 1,000 C.
Yeah, it might.
High it would get.
Yeah, I don't know. That's a good question.
Yeah, I wonder if it would cause, interesting reactions or a meteor, but I know we're getting down a rabbit hole. Just curious about it. Do we see evidence of bombardment on the surface of Venus? Like the moon, it seems to be pretty easy, but Venus, maybe not.
Right. So exactly, you have completely different case scenario with the moon where there is no atmosphere. So anything that comes within the moon's orbiting radius, it's going to hit the surface, and we're going to be able to see evidence of that. For Venus, for the most part, there is some evidence of bombardment, but there isn't as much as many other planetary bodies. And one of the reasons some people in the community think that is that Venus may have undergone some sort of resurfacing event due to volcanoes in its relatively recent past. So we're still talking millions of years, but they predict that the surface is actually fairly young compared to many other bodies within the solar system. And so it may have completely wiped away all the evidence of previous impacts, including during the heavy bombardment phase.
Oh, wow. And what is the age of Venus supposed to be relative to the age of Earth and, the other planets in the solar system?
It's expected to be about the same, but, future tests will tell us about that. We haven't been able to actually take that measurement of the rocks yet.
I was going to joke and say in the control room when you guys land, you should play that song Venus by Shocking Blue. I'm Venus, I'm your fire.
I will make that recommendation.
Yeah, make it lively and exciting. You'll be excited.
Absolutely. Oh, we will definitely be excited.
So when is this going to occur? When will you, the probes first get, into orbit and then start collecting data?
Yep. So as I mentioned earlier, we are preparing for a launch in the 2030, 2031 timeframe. Depending on when we launch, depends on our exact orbital trajectory. So, but we are expecting to be able to drop the atmospheric probe within about a year or so after launch. In the meantime, we may be able to conduct some flyby phases of our mission, in which case we're going to be able to take measurements with our two instruments on board our spacecraft, one of which is called Visor and the other is Cubis. And what these do is take different IR and visible and even UV measurements of the surface as we fly by the planet. And they're going to tell us more about the surface when we're taking measurements within the IR range, some information about its composition, but also by measuring in the UV visible range, we're going to be able to learn more about the clouds of Venus. We're going to be able to take basically movies of the cloud motions. And one thing that we are, really hoping to take measurements on is what people in the Venus community call the unknown UV absorber, which is, as the name, indicates, it's an absorber that's within the atmosphere that absorbs up to about 50% of the incoming radiation to the planet. And so it clearly has this profound effect on the atmosphere of Venus, but we don't know what it is. So hopefully with Cubis specifically, we're going to be able to measure that.
Yeah, very cool. Okay. Well, so where can listeners keep tabs on the Venus mission? I know it's still a ways away, but when the time comes, where can they go? Or even now, where can they go?
Yeah. So we have a couple of websites for Da Vinci. I can send it to you later, but it's like the actual website for you. But if you go to nasa.gov, you'll be able to search for Da Vinci.
Okay. Well, very good. Very good. Thanks so much for coming on the podcast. I really appreciate it. It's unusual stuff that you're doing, and I get the feeling it just takes so much patience. You have to wait a year for this, 5 years for that, planning. So it's really cool what you do. But thank you.
Yeah, thank you. You're not wrong. It does take a long time, but I'm getting to do what I love, and so I'm enjoying every single day of it.
Excellent.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.